Now write down all the formulas which we'll use in the DC motor or generator. Okay. So we are having basically generator. Basically we are talking about the DC shunt generator. For DC shunt generator formulas are different. For DC shunt motor formulas are different. Okay. For DC shunt generator, IA would be equal to IL plus ISH. Here IL is the line current. In some book they have mentioned line current, or in some book they have mentioned totally the supply current. So one and the same thing. Don't get confused. I is the total current basically. Okay. And for EMF, we are having, that is E is equal to V plus IA RA. But for motor, like this is for the DC shunt generator, now we are having DC shunt motor formulas are different. What is the difference here? IA is equal to IL plus ISH, but in this IA is equal to IL minus of ISH. Okay, or we can say IA is equal to I of minus of ISH. But for EMF also it is different, that is E is equal to V minus IA RA. Okay, now see what is the difference between the generator and the motor. For generator, we are having shunt winding and the armature. This circle is armature basically. Okay, in the DC shunt motor, we are having winding and the armature, and like this. So in DC shunt motor is taking inside the current, right? So the current is moving inside, that is I. So in armature also it is current moving inside, that is IA, and in shunt also it is ISH. So if you'll apply the Kirchhoff current law, you will get the same formula, that I is equal to IA minus IS. Okay. Now for this generator, this is sorry, this for generator current is moving outside, because in generator we are getting the current na, so that's why current is moving outside. So in armature also current is moving outside, because armature is generating current. But in shunt is basically used for making temporary magnet. For making temporary magnet, the current would be needed, so it would be ISH. If you'll again apply the Kirchhoff current law, the formula would be that IA would be equal to I plus ISH. Clear? This is the main difference. Now next formulas which are common for DC generator and motor, that is, wait, E is equal to Pn Z5 divided by 60A, that I told you. P is the number of poles, right? And N is the speed. This N is speed in the RPM, that is rotation per minute. If you'll take it in second, then in that case you have to convert it. Clear? Z is the total number of armature conductor, and phi is the flux per pole. Okay, and I told you about A is the type of winding. For lap, A value would be equal to P, and for wave, A value would be equal to 2. Clear? Now we are having formula for the torque also. What is the formula? That torque average that we have just now, that torque average, that is how much? Pz divided by 2 pi a into phi into Ia. Torque average is Pz divided by 2 pi a into phi into Ia. Why I have write down this separately? Because these are the constant terms. We can't change these terms, number of poles, number of armature conductor, and type of winding after making the motor. So this is the torque formula. Next formula we need to study about the torque useful, or we can say torque shaft. One and the same thing, that is the shaft, torque produced at the shaft. Okay, so in that case formula would be how much? Torque shaft or torque useful would be P out multiplied by 60 divided by 2 pi n. Okay, where 2 pi n is again the speed. Clear? Now one last formula, there is a relationship between that is shaft, torque. We can say it as a shaft torque. Okay. Now we are having one more formula, that is there is a relationship between EMF and speed and the flux, that is E1 is equal to N1 into phi 1 divided by E2 is equal to N2 into phi 2. Okay, how this formula come? This formula comes only from this E is equal to Pn Z phi divided by 68, because once the motor will make, E will be as it is, P is the constant because we can't change number of poles, Z is also the constant, we can't change number of conductors, A is also the constant, we can't change the type of winding. So we can write on K into N phi. Only we can change is speed by changing the current, or we can change the flux by changing the current. Okay, so E is equal to K N phi. Sometimes if these constant values are not given, we will use this formula. Clear? One more formula we are having, that is, I told you that E is equal to V plus IA RA for the generator. Remember, for generator I told you E is equal to V plus IA RA, plus if there is a voltage drop across brush, then we have to consider that one also. Voltage across brush for generator. For motor, we are having E is equal to V minus IARA minus voltage drop across brush. If it is positive, then we'll add voltage drop across brush. If it is negative, then we'll subtract. Clear? These